Question number 52 CY 2015, and the question is, when one CO group is replaced by PPH3 in CrCO whole 6, which one of the following statement is true? Option A, the CrC bond length is increases and the CO bond length decreases. Option B, the chromium and carbon bond length decreases and CO bond length decreases. Option C, the chromium carbon bond length decreases and CO bond length increases. And the last, the chromium carbon bond length increases and CO bond length increases. So you have to choose the correct answer among these four options. Now coming to the answer. To answer this question, we have to know one thing, that is pi back bonding. In metal carbonyl complexes. What is that? So the complex in question is CrCO whole 6, which can be draw as, okay, here the chromium is bonded by the carbon of the carbonyl. Now what kind of bonding is possible here? First, metal ligand sigma bond. For that we need one metal empty p or d orbital and filled sigma orbital of CO. You can easily see here, this is the head-on approach of the two orbitals, where the metal orbital is empty and the ligand has sigma orbital, sigma bonding orbital. Thus, the electrons are coming from the carbonyl to metal to form this metal carbonyl bond. Now, one more kind of bond is possible, and that is here it is filled d orbital of metal, and this is empty pi-star orbital of CO. This bonding is called pi back bonding, where the electrons from metal d orbital, filled metal d orbital, will go back to the pi-star orbital of CO. This kind of uh, pi bonding interaction is happening, that's why it is called pi back bonding. Now this is a very much well known effect in metal carbonyls. Now if we put another ligand in the metal carbonyl, so in the complex it is given PPH3. So what will be the fate of the complex? The complex will become Now, another factor you have to know, that is pi-acceptor ability order of different ligands. Now, what is the order? Nitrosyl is greater than carbonyl is greater than PF3 greater than Rn triple bond C greater than PCl3 greater than POR3 greater than PR3 greater than RC triple bond N. Here the carbon atom is bonded with the metal. Here the nitrogen atom is bonded with the metal. And last greater than NR3 on amine ligand. So our ligand, that is PPH3, is falling here PR3. That PR3 can be changed to PPH3 where R is to pH. So the pi accepting ability of this ligand PPH3 is very less with respect to carbonyl. Thus, when this ligand is incorporated in a metal carbonyl, carbonyl does not have any competitor ligand with this pi bonding ability. Thus, the pi bonding effect will be on the carbonyl only. Now, PPH3 is a good sigma donor ligand. Thus, what will happen after the incorporation of PPH3? More number of electron will be on the chromium now, and that electron will be distributed from chromium to carbonyl through pi back bonding, and this effect will be maximum in the trans CO group, that is the trans CO to the CrPPH3 moiety. This is this CO compound and this CO ligand, and because of this fact, what will happen? The chromium C bond will be shortened, and CO bond, since excess electron is coming from chromium to carbonyl, that and it will coming to the pi star orbital of CO, thus the bond order of CO decreases, thus the CO bond will be elongated. Thus you can easily got your answer that CRC bond length decreased and CO bond length increased. So your answer is option C, where CRC bond length is decreased and CO bond length is increased. So your answer is option C. You can find the reference. You can find the reference through the lecture on methyl carbonyl complexes by Professor Prosenjit Ghosh, Department of Chemistry, IIT Bombay, and these are the YouTube link of the required lectures. Thank you, video.